My dear students, welcome to part 2, the properties of the oscillatory motion. At the end of this video, you will be able to recognize the concepts related to the oscillatory motion and their properties, conclude the relation between the periodic time and the number of complete oscillations, recognize the relation between the frequency of the oscillating body and the number of complete oscillations, and finally appreciate the contribution of scientists in studying the oscillatory motion. Properties of oscillatory motion are expressed in terms of many concepts such as amplitude, complete oscillation, periodic time, and finally frequency. Now let's talk about number 1, the amplitude. The maximum displacement or distance of the string away from its rest position or equilibrium in the first side equals the maximum displacement of the string away from its equilibrium or rest position in the other side. So you can say that the amplitude is the maximum distance done by an oscillating body away from its rest position. Again, as you have learned, amplitude is the maximum displacement done by the oscillating body away from its rest position. So, if you look at this figure, you can imagine that this body here in position A is moved towards the position B, then from B to A, then from A to C, then from C to A. Each displacement of them is called an amplitude, and all of those displacements are equal. The measuring unit of amplitude is meter or centimeter. Now let's talk about number 2, complete oscillation. Look at this figure and imagine that you pull this simple pendulum and leave it. You will find that it's moved from the first position A to the second position B, then from B to A, then from A to C, and finally from C to A. Now you have 4 amplitudes, and 4 amplitudes equals 1 complete oscillation. So you can say that complete oscillation is the motion of an oscillating body when it passes by a fixed point on its path 2 successive times in the same direction. Complete oscillation includes 4 amplitudes. Look at this figure. The displacement from A to B is the first amplitude. From B to its rest position again, A is the second amplitude. From A to C is the third amplitude, and finally from C to A is the amplitude number 4. Now you have 4 amplitudes, so you have 1 complete oscillation. Number 3 is periodic time. It's the time taken by an oscillating body to make 1 complete oscillation. Unit of measurement is second. You can determine the periodic time through the following equation. Periodic time equals time in seconds over number of complete oscillations made in that time. Number 4 is frequency. Frequency is the number of complete oscillations made by an oscillating body in 1 second. The lower number of complete oscillations will lead to low frequency. On the other hand, the higher number of complete oscillations will lead to the high frequency. You can determine the frequency from the following equation. The frequency equals number of complete oscillations over time in seconds. Unit of frequency is hertz, and there are 3 fractions of hertz. Kilohertz equal 1 times 10 power 3. Megahertz equals 1 times 10 power 6. Gigahertz equal 1 times 10 power 9. Now, let's conclude the relation between frequency and periodic time. From the equation number 1, which is periodic time equals time in seconds over number of complete oscillations made in that time, and equation number 2, the frequency equals number of complete oscillations over time in seconds, we can conclude that frequency times periodic time equals 1. And we can say that frequency equals 1 over periodic time, or periodic time equals 1 over frequency. At the end of this session, I want to thank you so much for good listening, and I want to remind you that you can find more tasks or problems on our online classroom on Edumodo learning platform. This video is created by Mr. Mohamed Hamdy, science teacher at Mansoura Royal Schools. See you next time.